Seems as if my gain is a little bit low, so hopefully you can hear me okay. This video is about circles. I want to point out that in fall of 2024, this is the setup of our course in algebra, and it's 1.7 circles is the text we adopted, and all in my open math. This video is not bad.
Welcome to a
whatsoever.
lesson on the conic
It's absolutely
section,
not
the
bad.
circle.
He goes through the standard form for the equation of a circle.
A circle is the set of points x, y,
and the definition of a circle, and we do all that kind of stuff.
Y minus.
His drawings are
this would be
as good as mine would be if I was freehanding it like this with a mouse, because they're quite terrible, but mine are quite terrible as well.
The quantity y minus.
You get the idea. That's 1. Really what we're looking for, is if
Next,
you get the idea.
The rate that are 2 units from.
And then he goes through a number of
A,
problems.
the coefficient.
And completing the square, which you'll have to do twice in this problem type. And I'm going to do all of that as well. I might talk about it differently, and I'm going to throw some Desmos in because my drawings would be terrible as well. So first of all, let's open up Desmos and let's just write the most basic formula for a circle that we could have. So that would be x squared. I suppose I should turn this light on so I can see my keyboard. Plus y squared equals r squared, and Desmos will understand that r has to be a constant because we're just going to have x and y's as variables, and so there's our slider, and our r's default at 1. So really what this means is I have a circle defined by x and y with r being a constant. In this case it's 1, and r is the radius. So when I have this standard form, for the equation of a circle, if h and k are 0, and h and k are a point, so if it is 0, if they're both zeros or at the origin, and we'll talk about what I mean by that in just a moment, then I have x squared plus y squared equals r squared, and r is the radius of our circle. So imagine I put in a 1 for x. I go over here, 1 for x, and wait a minute, what am I doing here? So imagine, let's say that again. If I put 1 in for x, what does y have to be for this equation to be true? This is the equation I have in Desmos right now. So this would be 1 plus y squared equals 1. Subtract 1, and I get y squared equals 0. So y must equal 0 when x is equal to 1. That's this point right here that I have highlighted with the little finger. Let's put this on presentation mode so everything's a little larger. This point right there. Okay? If I put a 1 in for y, we'll get the same result. We'll get 0 for x. So there's 1 for y and 0 for x. If I put negative 1 in for y, we'll get 0 for x. If I put negative 1 in for x, we'll get 0 for y. This point is, if I put, let's say, put negative 0.7, we'll try to keep the cursor there. If I put negative 0.7 in for x, negative 0.7, square that, plus y squared, whatever that is going to be, 1 squared is 1. This is going to be 0.7 squared, which is 0.49. Remember, 2 negatives multiplied to be a positive. Subtract this from both sides. I get y squared equals 0.51. Take the square root of both sides, and I get y equals the square root of 0.51. So let's look at this number because I have to move the cursor. 0.71414. 0.71414. 0.71414. 0.71414. Okay, so all of these are just, I put in an x, get a y, blah, blah, blah. And these are the y's that go with the x's to form this circle. And in my head, it's easier to think of, this is the equation for the circle, and this is the radius 1. Put a 1 in for r, I get this. If I put a 2 in for r, so I have to change the scale. I'm going to go from 0 to 100, step 1, and it's going to give us a slider. And if I just move this up just a smidge, there's radius 2. So 1, 2, radius being the distance from the center point. The origin is the center point of the circle. I told you we're going to talk about this in a second. This is the center point for the circle. This h and that k. Note that the minus sign is part of the equation, not part of the numbers. Okay? H is the number when I write x minus some number. K is the number when I write y minus some number. I'm talking about this because this might be the first time you've seen transformations. It depends on how your high school taught transformations or didn't. My high school didn't really teach transformations regarding the h and k. You saw it when you had the vertex form of a parabola, but we didn't talk about it as transformations. Okay, so if I change this to a 3, can we see that this circle is going to have a radius of 3, and so it'll be out here, going through this point, that point, and this point, and that point, and all the ones in between, forming a circle. So 3, 4, 5, 6, 7. That's 7. Okay? So now I have this fairly large circle. I'm going to bring it down just a tiny bit, maybe to 5, for no specific reason. Okay, now I'm going to type in another circle. Oh, wait, I can do it this way. So I'm going to change R so I can change this one without changing the other one. We're going to call this, I don't know, G. Okay? And this one I'm going to type it. I'm not going to use a slider. So let's first make it 5 so that it's the same as the one we just had. Okay? If you're not sure how to do this in Desmos, you can turn this off. If I turn this off, the red one will show. And if I drag this up, the red one's going to be on top of the purple one now. Okay? Purple one's behind there. Because this one's always going to be on the bottom, and then as I add things below it, those things will lay on top of the others. Okay? So purple on top, red on the bottom. And I'm going to change this one to also look like it's in standard form. So like this, and I put the minus h. Now I'm going to need a slider for h. I'm going to put this at 0. And then we'll do the same thing with the y, except use the letter k. And then k will be a slider as well. And we'll set k's slider to 0. Okay? Now watch what happens. I'm going to leave the radius fixed for both of these so they're the same size circle. If I change h, right now, if we look over the iPad, right now my equation looks like this. X minus 0 squared plus y minus 0 squared equals 5 squared. If I had a 25 here, keep in mind that 25 is not the radius. The square root of that 25 is the radius because this is r squared. So 25 is equal to r squared. Take the square root of both sides and I get 5 equals r. A radius cannot be negative. Okay. So I am now going to write this. I'm going to change my equation so that it looks like this. I'm going to change this 0 to a 2, meaning I'm going to change h to equal 2. And I'm going to leave y alone, so it's still going to be y minus 0, or y squared. And I'm not going to change the radius. So when I change this h to a positive 2, the purple circle shifts to the right 2 units. It shifts to the right 2 units. 1, 2. Or over here, 1, 2. Or, lower at the origin, 1, 2. my arrowhead, my cursor, is now at the center, new center of the circle, or the center of the purple circle, which is the red circle shifted to the right 2 units. I shift this to the right, so h is positive 2, shift to the positive x direction 2 units. That is why we want to think about this minus sign as being part of the equation, and not that h is negative, because that would be counterintuitive. It'd be counterintuitive to say, oh, I have a negative 2, which is a shift to the right. No, you have h is equal to 2, which is a shift to the right. So, in addition to that, I can shift vertically by changing the value for k. X minus 2, I'll leave alone, plus y minus 7, which means I'm going to shift it up 7 units. Why? Because k is equal to 7. Oops, k is equal to 7, which is in the positive y direction, so that's up 7 units. So now if I slide this slider out for k 7 units to the right, or to positive 7, my circle shifts up 7 units. 1, 2, 3, 4, 5, 6, 7. There's my new center point. 7 units up from the x-axis. Or you can say my center point is 2, 7. Now, if I wanted to, let's go back to zeros. Let's lay the purple one right on top of the red one. And let's say I wanted to shift this down 3 units. So hopefully you can see that I would just take k, which is my y, or my vertical shift. It's adjusting this y value, so y minus k. It's being applied to the y value. I would shift this, if I would shift it down 3 units, I'd change this k to negative 3. But what that looks like in my equation is I have x squared plus y minus, here's the negative 3, that's k, which means I get something that looks like this. Y plus 3 squared equals 5 squared, or 25. That's not a shift to the right. A shift up, not a shift up. It is a shift down, because we should think of it as y, put that minus sign back into the equation, because that's the base view, or what the base equation looks like. And this has to be a negative 3 for it to be equivalent to plus 3. So this is how we should write it or see it in our head, such that k is equal to negative 3, which is a shift down 3 units. Okay? So now when we start thinking about the problem sets, the types of problems we're going to get in here, we get one that looks like this. Let me blow this up. Write the equation of the circle centered at negative 7, 6 with radius 16. So they're telling you that the center point is negative 7, 6, and radius is equal to 16. Remember, when we're watching videos, you should hit pause right now. You should try to answer this question, and having done so, then you'll hit play to check to see if you did it correctly. I'm not going to pause, because that's just annoying. You can hit pause yourself. I'm not going to wait here. So here's my generic form. Oh my goodness. Generic form of this equation, for the standard form for the equation of a circle. Y minus k equals r squared. If you write this every single time, you won't have to go someday and memorize it. You will have internalized it by just writing it down before every single problem. That's my recommendation for pretty much anything that you think that you have to memorize. Just write it down every time you go to use it. Now, if they tell me my center point is negative 7, 6, I'm going to do this. Substitute this negative 7 in for h. And substitute this 6 in for k. Substitute the 16 in for r. And then I get x plus 7 squared plus y minus 6 squared equals 16 squared. You could put 16 in your calculator, and I think it's 256. I don't know why. Yep, 256. And you can write 16 squared, type 16 squared or 256 into MyOpenMath if you desire, whichever one you want. And boom, that's our answer. The second problem is I would say essentially the same problem. You have to just manipulate this 14, right? Because the diameter is twice the radius, so you'd have to take this and divide it by 2 to get the radius of 7. So this will have x plus 4, much like this had plus 7, squared, the quantity squared, plus y minus 3, the quantity squared, equals 49, or 7 squared. This one is a longer problem, so we're going to do that one now. We have to incorporate some other ideas in here. So, find or write the standard form for the equation of the circle. Of course, again, like I said, write this down each time, and you will not have to, quote, memorize it. You will have internalized it, which I think is a better state of affairs in our brains. Okay. It has a diameter equal to, well, no. It has a diameter. So I'm going to quickly do this. Let's go back to geometry, which is some years ago. If I have a circle, there are a number of things that we can talk about. This line is tangent. You'll need this when you get to pre-calculus if you're going there, or if when you get there. Tangent intersects a circle once. It's a line that intersects a circle once. So here it is intersecting. So many of you will think of it, quote, touches the circle once. It's actually intersecting at a single point. One of those x comma y's that make up this, this is infinitely many points, x comma y. Okay? That's a tangent. A secant is a line that intersects the circle twice. We have to define it as a line intersecting the circle twice, because if we don't say that it's a line, it could do this. It could be a segment and do this. And that is not a secant. That is a chord. And that's where I'm heading. Okay? And you can't have a line that goes from here to here and not intersect the circle twice, because it will. This continues on, right? Okay, so then I'm trying to get to this idea. Here is a thing called a chord. And a chord is a segment with endpoints on the circle. So here's an endpoint. Here's an endpoint of the segment. The endpoints are on the circle. And so that's a chord. Now, there's one specific chord that is called the diameter. It's actually a physical thing, not just a number. So a diameter is a chord that passes through the center point, or includes the center point. And so there's only one of those. Yes, there's multiple locations of that one, but there's only one diameter. Or I suppose that there's infinitely many diameters, but they're all those diameters, all those chords, all those segments have the same length. So when they say they have a diameter, it has endpoints this. They're really telling you that about the physical thing, not the number. So when I have an XY axis here, my drawing is not going to be specifically precise. I have a point at -10, -2, so that's like all the way to the left on my little diagram, down a little bit. So this is -10, -2. And then I have another point at 4, which is maybe half-ish that distance, and -8. So I'm down here, maybe like this, 4, -8. Okay, so I have this chord that has these endpoints. Hopefully I did that poorly. There we go. And that's the diameter of a circle. So my circle looks, hopefully this isn't going to be too terrible. My circle looks kind of like that. That upper half is a little bit flat and the other one's a little bit fat, and it doesn't look like this is in the center, but it's intended to be. Okay, maybe I can do that again. Let's go forward. Let's do this. I think I can do this. If I hold this, I'll make a good circle. Made an ellipse. Now I'm making a balloon of some sort. I don't know why it shaded it. Where are these shapes things? Do this. Okay. Can I select it and then drag it over here and then size it? All right, I think that's better. Okay, so then this is the center point. Here are the endpoints. There's that diameter, okay? They want to know what h and k are, the coordinates for the center point, and they want to know what the radius is. So we have to do a number of things. We have to use what many folks will call the distance formula. And this is just one way. There are multiple ways to do this video. So distance formula. I don't think of it so much as a formula. It's really just the Pythagorean theorem. So what are we doing when we use this quote distance formula? We're drawing a horizontal, or thinking about a horizontal line or segment and a vertical segment such that I create this right triangle. And what I'm taking is the x coordinate here and the x coordinate from the other point, x2 minus x1. We're going to square that. And so that's this distance squared. I shouldn't label it there, but that's okay. Plus the y coordinate from up here, we'll call that y1. We'll call that y2. That's the coordinate over here, so that's -8 minus -2. Oh, I'm not writing it that way just yet. So that's y2 minus y1 squared. And the hypotenuse, which is the diameter, so we'll go d squared is equal to that. So it's the Pythagorean theorem. So if you want to memorize something, go ahead and memorize. I wouldn't memorize that just yet. I'll give you the next step. We'll memorize that thing. But if you just want to remember that it's Pythagorean theorem, it's a right triangle, then there you go. Okay, so this is what I would memorize. Take the square root of both sides and we get this. x2 minus x1 squared plus y2 minus y1 quantity squared. If that's what you want to do, memorize that thing. That is what people call the distance formula. So I'm going to substitute some x's in there. I'm going to choose this as x2, so that's 4, minus -10 squared plus y2 is -8 minus -2, that quantity squared. And so I get 4 plus 10 squared plus -8 plus 2, which is -6 squared. And so I get 14 squared plus 36. And 14 squared is 196, I want to say. Yep, 196. 196 plus 36 is 196 plus 36 is 202, 232, or so I believe. I could be wrong, but we'll find out. And that's the distance of that diameter, the distance between those 2 points. That's the length of that chord is the diameter. It's also called the diameter, so that's the square root of 232. I wouldn't worry about simplifying it. That's just me. If I want to know what the radius is, this number down here, then I just have to take that and divide it by 2. D equals 2 times the radius, or the radius is equal to the diameter divided by 2, which in this case is 232, square root 232 divided by 2. I would just type that in. I don't know what they're going to do. Yeah, they're going to do that, of course. Square root SQRT 232 divided by 2. And we'll submit now and see what happens. See, it's green. That is 7.615, blah, 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 blah. But I don't want to make errors, so I'm just going to type that in. That's just me. Now, I need to find the location of this center point. How do I do that? You can find the midpoint. And people call this the midpoint formula. It's not really a formula because there's no equal sign. To determine the midpoint of a segment joining 2 points, you would do the following. Find the average of the x's. So in other words, let's get blue going. If I have this segment here, the average of those 2 x values will be this point in the middle, which is the same x coordinate for the center point. If I do the same thing for the vertical, find the average of the 2 y values, I'll find the y coordinate for that the midpoint or the center point. They will be the coordinates of the midpoint of that segment, which in this case is the center point for my circle. So that quote formula for the midpoint is this. We'll put M, capital letters, labeling points in coordinate plane or geometry. The average of the x's, comma, average of the y's. Okay, so memorize that formula or just understand. Take the average of the x's and take the average of the two y's. If I do that arithmetic, I'm going to substitute x1, which is 4 or whatever, negative 10 plus negative 10. Divide that by 2. Yeah, adding so we don't care in what order, right? 2 plus 3 is the same as 3 plus 2. So the order in which we add does not matter. So negative 2 plus negative 8 divided by 2. So we get the midpoint to be negative 14 halves, which is negative 7, and 2 plus negative 8 is negative 10 over 2, which is negative 5. So we get a midpoint of negative 7 comma negative 5. And so my h is negative 7. Whoa, what did I do wrong here? Yeah, that doesn't look right. Oh, because I added this wrong. Oof, that's not good. That's negative 6, which gives me negative 3, which is that, and this is negative 5. Sorry about that. Mathematical error. So negative 3 comma negative 5. This error right there. 4 plus negative 10 is not negative 14. 4 plus negative 10 is negative 6. Divided by 2 is negative 3. Okay, so this problem is complicated. By the way, you will see this problem again. You will see this problem again. Maybe in a month. Hint. Okay. Here's the more difficult of, well, some would say the more difficult of the problems that we need to see or encounter. The rest of the problems we're not going to worry about. I think you can get around it and figure it out. This one, you haven't seen this in a while, possibly. So this involves what is called completing the square. A process called completing the square. You will have learned it when you were completing the square to solve quadratic equations. So we're going to do one of those first. And I'm just going to make it up. I'm going to pull it out my tuchus. X squared minus, let's make it 6x. Let's make this minus 5, not minus 5. Do I want it to be minus 5? Yeah, minus 5 is fine. Equals 0. And so I have this quadratic equation. We're going to do this, and then we're going to do two more times with the circle thing that we have in front of us. If I tried to factor this, right, negative 5 gives me factors of negative 1 and 5, and 1 and negative 5, but neither of those adds up to negative 6, so I cannot factor this. Yes, many of your teachers, if you're trying to solve this, would have let you resort to the quadratic formula. I'm going to say let's not resort to the quadratic formula. Actually, let's do the quadratic formula very quickly, just do a comparison. If I use the quadratic formula, which is that, this is a, so a is equal to 1, b is equal to negative 6, c is equal to negative 5. So I get negative b, which is negative negative 6, plus or minus the square root of negative 6 squared, the quantity squared, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times 1. So I get 6 plus or minus the square root of 36 plus 20 over 2, which is 6 plus or minus the square root of 56 divided by 2. Okay, so that's the number that I get. It's not a particularly beautiful number, 56. 56 is divisible by 4, I believe. 1, 4, 16, 4. Yep. So 56 is the same as 4 times whatever that was. 14. Okay. So I'm going to simplify this. I wouldn't particularly do it if there was a problem, if it was a problem that I was doing, but this is 4 times 14. Let's double check that. 4 times 14 is 56. And we get that. And then I can take this 6 plus, this is the number 2. So I get that. And then if I divide this 2 into both of those, I get 3 plus or minus square root 14. Okay? Those are my two answers for this quadratic. I'm going to write it up top and then erase it. So I get 3 plus square root 14, and I get 3 minus square root 14. Okay? All right, I'm going to erase all this stuff, and I'm going to solve the same thing using the process called completing the square. This was not a trivial thing. I just made those numbers up, so I get this not so beautiful answer. But this is what you're going to get with, this is potentially what you're going to get, or probably what you're going to get, if you have a non-factoring quadratic that you use the quadratic formula to solve, or in this case, use the completion square. The first thing I'm going to do is I'm going to add 5 to both sides. So I'm left with x squared minus 6x equals 5 on the right-hand side. I'm going to leave a whole bunch of space here. I'm going to leave a whole bunch of space here because I get to choose, you and I, whoever's doing the problem, gets to choose to add whatever they want over here. If I want to add 37, I can add 37. Remember, if I add 37 to the left, I must also add 37 to the right. But this 37 is not what I want to add. But what I'm getting to the point is you're choosing to add this 37. It's just you want to choose what you add there to be a number such that you create this situation. You create something that is factorable, and this thing's going to be a perfect square trinomial. It's going to be x minus something, x minus something. Why is it going to be minus something? Because these SIGNs have to match. These signs have to match. And it's going to be like x plus 2 times x plus 2, or x minus 2, x minus 2. Doesn't matter. I'm going to show you. I get x squared plus 2x plus 2x plus 4, which gives me x squared plus 4x plus 4. That's a perfect square trinomial. I could also have a 7 here. Let's see what happens when I have a 7 there. 7, 7. I get x squared plus 7x plus 7x plus 49. Notice that, just like others, this is the square of half of that. Why is it half of that? Because this 7, that's 7. This is 49. It's the square of these two numbers. This begets that, and this 7 gives us that one. The product of those two 7s gives us 49. So if we see that pattern, let's do it a third time. And let's put a 5 in there. Let's make it a negative 5. Okay, so if I put a negative 5 in here, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is plus 25. So in other words, these two numbers become negative 10x. And then those two numbers multiply to become 25. So to find out what this number is that I need to add here, I need to take this middle value, this one, negative 10, or in this case, negative 6, and divide it by 2. So this is going to be the number negative 3 and negative 3, which leads us to this thing. Because those two multiplied, I can write it more efficiently as that thing squared. Okay, those two x minus 3's multiplied can be rewritten as x minus 3 squared. That's why this is called completing the square. You're choosing to add something to this trinomial, which is currently a binomial, such that it completes the thing to be square. Okay, so if these are negative 3's, if I went backwards, x times x is x squared, negative 3 times x is negative 3x, x times negative 3 is negative 3x, and I get negative 6x. But when I multiply this negative 3 and negative 3 to get this third term, the constant, that'll be plus 9. So we're choosing to add 9 here, which means we have to add 9 on the other side. Bring all this down, and I have a 14 here, and this x minus 3 squared. So I have x minus 3, the quantity squared, equals 14. Square root both sides. I get x minus 3 equals plus or minus the square root of 14. Add 3, and I get x equals 3 plus or minus the square root of 14, which is exactly what we have up there. The quadratic formula is this process, but with just letters. If I had this, ax squared plus bx minus c, plus c equals 0. If I subtracted c from both, I'm not going to do the whole thing out because that would be painful for most of us. This is negative c. This is the start of development of the quadratic formula. I would take everything divided by a, I would take everything and divide b in half and add that thing back in, square it and add it back in on both sides, on blah, 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 and then solve for x. That is that process. This is completing the square, okay? And so I get that solution. So now, let's do the same thing for a circle. The problem or the effort is I have to do it twice. So typically your problem is given to you like this: x squared plus y squared minus 6x plus 4y plus 9 equals 0. First thing, subtract 9 from both sides. When I rewrite this, I'm going to put the x's together in a space and put the y's together in a space. So x squared plus, x squared minus 6x space, and I'm going to use a different color, plus y squared plus 4y space equals negative 9. Because remember, I subtracted the 9. Okay. In the same way, I'm looking for, I'm looking for that thing, which eventually will be that thing, x, x, x. Because this is a minus sign, this will have to be minus signs, and this will be a minus sign. Because remember, this third line here, this x minus something quantity squared, is the same representation of that, just consolidated as a square instead of two binomials being multiplied. I'm going to divide this by 2, recall, to figure out what number goes there. So that's going to be negative 3, and of course then this is a negative 3. And then I'm going to square these two numbers, or multiply those two numbers, which is squaring negative 3. What's negative 3 squared? We'll write it down later. Plus negative 3 squared. That's 9. If I added negative 3 squared over here, which is 9, I have to add 9 to both sides. Okay. Now, with the y's, I'm doing the same thing. I'm doing the exact same thing. Let's stick with the same color scheme I'm doing here. So this is plus. Now I have these two binomials. This is going to be y. This is going to be y plus. This is going to be y, the quantity squared. Because this is a plus sign, this is going to be plus, plus, plus. And then half of 4 gives me this number, which is 2. And then 2 multiplied times 2 gives me 2 squared. That's what I'm adding. And so since I'm adding 4 to the left-hand side, I have to add 4 to the right-hand side. So now I'm down to this. X minus 3, the quantity squared, plus y plus 2, the quantity squared, equals negative 9 plus 9 is 0, plus 4 is that, or if you prefer, you can write it as 2 squared, because that's r squared. So what is my r? That's going to be 2. What is my k? That's going to be negative 2. And then h is going to be 3. Okay? So I gave you 3 examples of completing the square. They were all different. When we go to graph this, we're going to graph the center point, 3 comma negative 2. So go over to x equals 3, go down to negative 2. I click, and then when I stretch this out, I'm not holding the click. I just clicked it once and let it go to get the center point. And I'm going to drag this out to a radius of 2. If you try to drag it out like this, that's going to be all messed up. Just go to the right or to the left or to up or down and go over 2 units. Pow. Okay? Whoa, oh, because I didn't enter answers. But remember, that was 3, negative 2, and 2. I didn't enter them. That's why it's yellow, but the graph is correct. All right, that's it. It's a long enough video as it is. Hopefully this is helpful. This is probably a different explanation than the other video. Pick one, watch both of them, whatever helps.